Well, this few days I've been working on some of my legacy projects. This one here involves a uh, Arduino, but this is a Chinese clone or bootleg version of the Arduino. It uses a different but almost identical microcontroller unit. This is the well-known Arduino, which is cheaper than the Arduinos. But anyway, um, so this is a simple um script written based off the sample code that comes with the Arduinos. This is using the LGT 0F228P version of it. And all this one does here is that it establishes a serial connection, and it just waits for an R, upper or lowercase, to reply with the 6 analog channels. So this chip is an improvement of the conventional Arduino Nano. This one here has 6 analog channels, and it just happens the values every time you send an R, all 6 of them separated by a comma in ASCII format, and then adds a character return line feed to the end. And here I got the accompanying C# code that this one here is a Windows form. So here's the design of the Windows form. As you can tell, it has a plot here. And this particular one, I decided to make it so it will find the appropriate serial port, so I don't have to select it. It will find a serial port number and connect to it, because otherwise you need to look into the device manager and find the COM port. But with this snippet of code here, this function called check ports, it accesses the management object server method, and just like an SQL query, access the plug and play entity where there is a COM port. Now, I got this zip of code out of Stack Overflow a while ago. I've been using it to determine if I have, in this case, a CH340 chip, which is the one that comes with the Arduino, the CH340 USB to UART. So it looks for it, it finds it, and whenever you click connect, it will connect to it at a fixed baud rate. Like it's no, the baud rate here, it's 19,200 bits per second, same as the connect push button, which is right here. Connect. Where's that? Close. No, that's a close. Sorry. I'm looking through the screen of the phone, so that's a little connect. Okay, so if the port is found, it will connect to it, right? And let us just run it. Right, so it knows it found a device connected to COM port 3. So that's the device that has this particular chip in the serial port descriptor. And also I wanted to show you that I have connected a sensor to the Arduino. This here, I got it from a blood pressure portable unit, and it's basically this device here. Let me just open it up here. This is on downloads. Let me just click downloads here. Where's downloads? Oh, there it is. So it's this device here. So it's the NXP Freescale Semiconductor NXP. So it's this device here, which is a 0 to 10 kilopascal pressure transducer, right? Single port. And the pinout is just this is a pinout, right? It's got 5 volts ground, voltage out. Very simple, straightforward connection. So if I were to connect to it, that is the current pressure at the port. And you can see the LED on the Arduino is blinking. That's because I am requesting the values every 500 milliseconds. So this is the Visual C# form, and I got a background image on it. It kind of looks like I wanted to make it look modern, sort of. So the cool thing about this Arduino is that it goes from 0 to 4095, which is 12 bits in total. So let me see. It's actually 12 bits. Let me double check that. Let me check that for you. Just done that. 2 to the 12 power. Yep, 12 bits. So it's 12 bits resolution. That's cool. Normal Arduinos you get up to 1024, which is, I think it's what's that to the 10. Yeah, so 10 bits versus 12 bits. So this one here is 12 bits versus the normal Arduino Nano, which is 10 bits. We get a finer resolution here. So that's why the scale goes up to 4095. Here I have a little DC pump, again from the same blood pressure portable device, and I'm going to plug it into the port, and I'm going to connect this adapter to this AC adapter to voltage to AC. You can see that suddenly there's a rise in the signal. So you can see if I were to plug the port, let's see if I can see that down here. Just minimize this. Oh, I cannot move it. Yeah, because I have no track qualities on it. But anyway, you can see the spike. So where to plug the port, you get those pressure spikes. So it peaks there, and it drops. It peaks there. That's the maximum pressure it can build, which I think it's 10 kilopascals according to the data sheet. And yeah, it goes up to 10 kilopascals right there, which according to the conversion rate, that's about 1.45 pound a square inch. So yeah, experimenting with random electronics. Again, thank you for watching.